In this video, I want to have a look at calculating the area of composite shapes. So a composite shape is made up of two or more basic shapes. So to find the area of a composite shape, we're going to break our shape down into smaller basic shapes and then either add or subtract those areas. So in our first example, we've got this shape here. We're going to break that into two smaller rectangles. So we can either break it along here, and then we can find this small rectangle up here and the bigger one down the bottom, or we can break it down here and we can find this rectangle and this whole rectangle here. So either way will work, they'll both give you the same answer. It's up to you which way you do it. If we chose to break it down here, we call this rectangle area 1 and this whole tall rectangle area 2. If you had it around the other way, that's okay as well. So if we found the area of this first rectangle, we've got a height of 6 and a length of 13. So our area there would be 6 times 13. And that would give us, so 6 times 13 would give us 78. And then for our second area, in this rectangle we've got a 7 and a 17. So we go 7 times 17, and that will give us 119. So our total area would be that 78 plus 119, which would give us 197. Now, because the shape was all in meters, that's going to be 197 meters squared. For our second shape here, we've got this big triangle, and then we've got this square that's been cut out of it. So we're finding the area of this shaded region. So let's find the area of the whole triangle first, as if it was still a full triangle. So that area would be, because it's a triangle, it's half times the base, which is 15, times the height, which is that 18. If we pop that in our calculators, we'll get 135. And then we need to find the area of this square as well. So the area of a square is just that 8 squared, and 8 times 8 would give us 64. So then to find the total area, this time instead of adding, we're going to have to subtract, because that area is the area of the whole triangle, and then we've cut out this square in the middle. So it's going to be 135 minus 64. And that would give us 72. Because all our measurements are in meters again, that's going to be 72 meters squared. All right, our last one, we've got this square on the top and then a semicircle down the bottom. So that's our area 1, area 2. So the area of our square would be 40 times 40, or 40 squared, which would give us 1,600. And for our semicircle, if that was a regular circle, we'd have pi times the radius squared. And now we know the whole distance from here to here has to be that 40. The radius is from the center of the circle out, so that's going to be half of 40, which means that our radius is going to be 20. So we'd have pi times 20 squared if we had a whole circle. Because we only have half a circle, we're going to chuck a half in front of that. So it's to say half times pi times 20 squared. So a half times pi, times pi times 20 squared will give us this huge whole number, and we're going to round that to, let's just do it to one decimal place. So we'll have 628.3. Then we're going to add those two numbers together to find our total area. We've got the 1,600 plus 628.3, which will give us 2,228.3, and this one's in centimetres, so that's going to be 2,228.3 centimetres squared. So it's a few examples of how we can find the areas of composite shapes.